we're looking at rounding off principles. So we'll be looking at rounding off the decimal places, significant figures, and we'll be writing some answers in standard form as well. So let us go. Let's see what's going on here for this question. Write the value of the square root of 101.6064. So basically what we want to do is just to take the square root of that number. So when we take the square root of this, the exact value is 10.08. So using your calculator, you take the square root of that. This is the exact value. Now, after getting 10.08, we want to represent that correct to one decimal place here. So I'm going to put it right here, 10.08 to one decimal place. Basically, I'm going to identify the digit that is in the first decimal spot, which is the 0. So one decimal place would be the first digit after the decimal point. So here's my decimal point. 0 is in the spot. The thing is, it's either the 0 will change to a 1 or it will remain the same. What we will use to decide that is the digit to the right of the spot, which is going to be the 8. So the idea that we're working with for this is if the digit to the right, in this case is 8, if it is between 0 to 4, the spot remains. But from 5 to 9, if it falls in those categories, 5 to 9 will add 1 to the spot. And in this case, the 8 is in the 5 to 9. So we're going to add 1 to this spot right here. So it becomes 10.1. So to one decimal place, it's rounded off to 10.1, and that's what we wanted. Now we're going to round this off to two significant figures, right? So we're going to round off this same number here to two significant figures. So we got 10.08. Now, remember, all digits are significant, except 0, which may or may not. So what it means, I have 4 significant figures here right now. 4. But I only need 2. So it means then I'm going to mark the digit that is occupying the second spot here. So that 0 there is a significant figure, because remember that zeros that are between significant figures are significant. So that is the second significant spot. Then I'm going to look next door. So when I look next door, because next door is a 0, it's going to fall in the 0 to 4 category, which means that I'm going to leave that spot as is. So my response to two significant figures will be 10, right? And for persons who think we should write, if you think we should write 10.00, this is actually 4 significant figures, so we have to be careful, right? Because remember, once you start counting significant figures and there is a decimal point in your mix, everything after that will be significant. So we cannot do this, not in this case, right? So there it is. So we're looking at 10 right there. We were also told to write this in standard form. So let's take a look. We have 10.08, and we want to put this in standard form. Remember, the idea for standard form is that the idea for standard form is like this. It's a times 10 raised to the n, where a is a number less than 10, but it could be greater than or equal to 1. And n is some integer, right? And if you don't remember what integers are, it's all the negative of the whole numbers along with the whole numbers. So those numbers, right? And 0 as well. So those are integers, the negative of the whole numbers, and 0. All right. So basically, we're going to move our decimal point until it's like this. So we're looking at 1.008 because that's the framework for standard form. The decimal point must come after the first non-zero digit moving from left to right. So it's going to be after the 1. And then we're going to check to see how many places did it move to get there, right? So Remember, we always say times 10, and then we're trying to see what power. Let's look. How many places did we move it? 1. So this is 10 to the 1. And the thing I normally look at, if my original figure that I'm conforming, that I'm transforming, that I'm converting is a number greater than 1, then my power will be positive. So this is a positive 1. Let's take a look at some other questions. All right, so in this question, we were asked to calculate 9.72 times 12.05 and write your answer as follows. So let us do that first. So 9.72 is something that you want to do on your calculator, right? And we're getting as an exact value 117.126. So this is the figure that we want to change to decimal places, significant figures, and we're going to write it in standard form as well. So let us get to it. We want to first look at representing this as 2 decimal places. Now, let me rewrite the figure. So here is a figure here. So it is 117.126. Currently, we have 3 places of decimal because there are 3 digits after the decimal point, and we're talking about moving from left to right, going that way. So there are 3 digits after the decimal point, right? So here is the deal. Let's identify the digit that is in the second spot. So if we look, this is a decimal point. Number 2 right here is the digit that is in the second spot. What it means is that this number 2 can either change to a 3 or it could be remain as a 2. So we would have to check the digit next door. So remember again, if the digit next door is in the category of 0 to 4, the spot remains. But if it is in the category of 5 to 9, and in this case, 6 is between 5 to 9, including the 5 and the 9, so we're going to have to add 1 to the spot. So this 2 becomes a 3. So what we're looking at is 117.13. And there it is. We would have represented that idea, as you see, to 2 decimal places. All right, let us keep going. The other idea is that we want to write our response correct to 2 significant figures. So let us look back at this. So it's 117.126. Now, what are significant figures? All digits are significant except 0, which may or may not be significant. There are no zeros here, so I'm actually looking at 6. I'm looking at 6 sig fig right here. So I'm looking at 6 significant figures, but I only need 2 for this question. So what I'm going to do is to isolate or just identify that second significant digit. And we're referring to this right here. Because remember, significant figures are counted from left to right. So this is that digit that is occupying that second significant spot. Now, the idea still remains. We're going to look next door to the right. And if the digit to the right, which is a 7, if it falls between 0 to 4, including those, we leave the spot. But if it falls between 5 to 9, from 5 to 9, we add 1 to the spot. 7 is between 5 to 9, so we are going to add 1 to this spot right here. So what we're looking at is 1, 2. Now, here's the issue with this sort of question. Some people may see this and think the answer is 12, but we're talking about giving value to the original thing. So the original thing we already know is actually 117, which means that for this case, you have to give value by using a placeholder to represent where the 7 was, just because you're giving back value to the figure itself. And at the same time, you're making sure that you're answering the 2 significant figures. Because remember, zeros at the end are not significant. They do give value for a whole number, but they are not significant. They're called trailing zeros. So in this case, 120 must be the answer, not 12, right? Because if you think of 12, you will be not giving justice to the value of 117 being rounded up, because you could see that this was rounded up too. So if it was rounded up, we cannot go back down to 12. We're thinking of, okay, this changed to a 2, add a 0 to the spot to make it 120. And that is the correct response that we need right there. Again, we're going to represent 117.126. We want to represent this in standard form. Remember, again, standard form is written in the format a times 10 raised to the n, where a is a number less than 10, but it is greater than or equal to 1. N is an integer. What are integers? We're talking about having our whole numbers along with 0, and the negative of these whole numbers, those are what we classified as integers. So let us set up the framework for our standard form. Remember again that the digit, the decimal point, I should say, must come after the first non-zero digit from left to right, which means that I'm looking at a framework that says 1.17126 times 10, and this 10 will be raised to some power, right? But let us check to see how many places did we actually move this for it to actually end up where it is. So let's take a look at the movements of the decimal point. It moved from here, 1, 2 places to land there. So then we're suggesting that the place of 10 was a 2, because every time you hop over one digit, that's one place of 10. So we hop twice. So that's 2 powers of 10 that we deal with. Now, should my 2 be a positive or a negative? It is highly dependent on the original figure, all right? Because this figure in the original problem is 117, that means it's greater than or equal to 1. It must be a positive power. Other people may say if you move your decimal point to the left, it's a positive power as well. So whatever works for you, you use it. So the answer is 1.17126 times 10 raised to the power of 2. Let's take a look at the last problem here. All right, so in this problem, what we have is we want to divide 7.021. We want to divide that by 6.751. So let's do that math. 7.021. We're dividing this by 6.751. And this gives us a value of 1.0399994. Right. So the thing is, other digits were here, but because the question really wants 3 decimal places and 3 significant figures, I'm just making sure that I have all of those places and just one more. But here I had 2 more places, but that's fine. So the bottom line is I want to make sure I cover these so that I can respond to them properly. So let us get to it. So 3 decimal places, this one. Let's first identify the digit that is in that spot. So let me rewrite this figure, 1.03999 and then a 4. So the third decimal place is the third digit after the decimal point. So it's going to be this 9 right here. And then context now for the question is that we have to observe the digit to the right of it, next to the right, to its immediate right. So it's a 9 as well. Here is the idea. If that digit next door to it, to the right, falls from 0 to 4, you leave the spot. In this case, you could see it's not. But if it is a digit from 5 to 9, the spot goes up by 1, which means that we're going to be adding 1 to that spot. Basically, you could see that a 39 became a 40, basically. So this becomes 1.04, right? So we're looking at 1.04 and then a 0. That's what is going on there. So 1.04 0 because we need 3 decimal places. So when you add 1 to that 9, it becomes a 0. You carry a 1 to here becomes a 4. So the answer is 1.040. For some of you, if you're struggling, you could look at the fact that a 39, when you add 1 to it because of this, it became 40. So you could look at it like that. You could look at it like that. So whichever way suits you, you could work. Now let's take a look at the significance of this. Now, we want to represent this idea to 3 significant figures. So let's write it 1.03999 and then a 4. So if we want to represent this to 3 significant figures, remember, zeros between significant figures become significant. So my third significant figure would be this, because significant figures are counted from left to right. So the first one is 1, the second one is a 0, the third one is a 3, right? Then when I look next door, I have a 9. Remember, the principle remains that if the figure next door, that digit, if it is a digit from 0 to 4, you leave the spot. But if it is from 5 to 9, you add 1. So we're going to have to add 1 to this spot. So we're looking at 1.04. So this answer is 1.04 to 3 significant figures. All right. See you next time. That's it.